Hello. I am Chris Hillman, and I am the lead developer at Parametric Systems. Perhaps a very brief summary of my career is helpful. 50 years ago I started in computing. Various jobs and roles followed, but having steady employment was not for me. In 1980, I branched out into contracting. I have always been interested in the idea that computers could be programmed to create applications. Many things happened, quite randomly, and by 2017 I felt I had enough technique to seriously attempt that development. Parametric Systems was registered as the vehicle for this, and Enigma is the product. If one is automating anything, it is best if the anything can be simplified. So, it was with automating the creation of a general application to create programs. An early decision was made to move the storage and retrieval of information out of the client/server programs to simplify the problem. From that came this. Security by design. Gartner produced this diagram of the current approach to security, and I should thank Hewlett-Packard Enterprises for bringing it to my attention. Here is shown 8 layers of security protection for the application. The protective layers are shown in the typical onion skin manner. Each layer has a particular function, and together they protect our applications. Do they really protect? Not very well according to recent reports. A brief look at the security problem is worthwhile. It seems that the pandemic and working from home have become a mecca for the bad actors. The cost is enormous. The rate of cybercrime is increasing. The targets are important infrastructure. Just how bad the situation is shown by the Australian Signals Directorate, the body charged with protecting Australia against cybercrime, having to supply resources to keep the Federal Health Department safe. A recent interview on ABC News Radio was with the Director, International Cyber Policy Centre, in the Australian Strategic Policy Institute. This institute is privately funded and advises government on computer security. The interview concerned this, but there was nothing new. Just the same, old stuff. What else has been happening? What does this tell us? What is done to fix the problem? IBM, when they were creating OS 360, found they had a 90% chance of creating 2 problems, for every 1 problem they corrected. Large software has its problems, and this makes it even larger. Why do we do this? Because it has always been done that way. And that is the nub of the problem. %84 of security breaches are in the application layer. Our industry spends $23 on onion security, for every $1 spent on application security. There needs to be a different approach. So, forget the same old approach. Think outside the box. Just because something isn't done, doesn't mean it can't be done. Take responsibility at the application level. Stop leaving security to the experts. Security is everybody's problem, so design with security in mind. This, security by design. Let us start at the beginning. What is being secured? The data, the information, the database. And here it is. It can be secured with a password for access, and data encryption to make the data less accessible. But it is not of much use sitting all by itself, so there has to be a program to make use of it. How should the program be secured? First, quarantine the program. Make sure there is no internet access. After all, that is where our security problems come from. I did mention thinking outside the box. Second, control the program functionality. Only code it to handle predefined requests and predefined outputs. Anything that does not conform to the definition is rejected. With no reason given. Just swallowed up, as if it never occurred. Compile the program. Interpretive programs are relatively easy to follow, if they fall into the wrong hands. Compiled programs are a relative nightmare to understand. Lastly, set the program for standalone, or background, operation. There should be no workstations attached to the data access program. Which does cause a problem. How do the requests arrive, and where does the output go? There has to be some method to control communication. This is the data access method, and it exists to pass on the requests and the outputs. It can be secured by encrypting the communications. It can also be made much harder to hack by a bad actor. For every request, the data access program can be loaded and, when the request processing is finished, it can be unloaded. The .NET environment provides for this. Also supply a key to access the request. Both the key and the request have to exist at the same time. This is not easy for a bad actor to create. Similarly with the output. Supply a notification that the output is available. And lastly, when a request has been received, it is destroyed. The same is done with the output. These should each have a transient existence of the minimum time possible. Less than 2 seconds. This makes it harder to intercept, trap, and study a transmission. There is one more section to add. Where are the requests sourced from, and where do the outputs go? The user programs, of course. An application is only useful if it can be accessed. These are normal client-server programs. They rely upon the onion layers for security. They never breach the application security by That is security using this application design. But wait, there's more. Add in some firewalls. Add more, or stronger, encryption. Use separate servers. Do all the development away from the production servers. Security is everybody's problem. The whole organization has to play its part in security creation. Let's summarize. This presentation has covered a general design and each section has been explained. For each section what the design recommends, why it is recommended, and importantly the security benefits that can be achieved, have been covered. There is no recommendation on how each section of the general design should be achieved. That is an installation decision. But the design is not as theoretical as might be imagined. It is implemented and it does work. Conversely, every step missed out or modified will weaken the security. Make it stronger if you can. Whatever your installation uses, as its preferred development environment, can be used to create this design. No extra software package is required, and no change to any existing software package is required. And lastly, a warning. It is likely that this design will be greeted with howls of rage, or derision. It is not the way security is done. This will only happen if you get support from the top, to make it happen. I'll finish with 2 thoughts before Q&A. Security is never perfect. I have spent a long time working with passports and passport issuing applications. All that is expected with passport security is to stay one step ahead of the bad actors, the counterfeiters. To end this presentation, have you been paying attention?